ASP.NET MVC2 Overview. In this nugget, we're going to kind of take a look at what MVC is, how it works, and what you can do with it. We'll start with an overview of the MVC model, talk about how the ASP.NET MVC framework actually works, and see an example, and I'll kind of walk you through it. Look at organizing your project into areas, using shared views between multiple controllers, and what routes are, what they're used for, how to build your own routes, and how to specify route constraints. Let us begin with a quick overview of what this MVC stuff is all about. Now, in a traditional ASP.NET application, you're typically building an ASPX file, which contains your HTML. It probably contains some JavaScript. Might include a few directives for the page, like registering different controls or whatnot. And then behind that, you have an ASPX dot, let's say VB. If you're working in VB, it would be C otherwise. And this is where all of your code lives. So these two together form the entire application. And when the server outputs this stuff, it produces the final HTML that's actually streamed off to the browser. And all of this code executes server side. So when someone clicks something, it results in a post back to the server, and this stuff executes. So this is the traditional model. Now, it does a great job of separating your user interface from your code, but it still ties these two together. If your user interface changes for some reason, then your code has to change too. If you remove a button, then you have to remove any code that was wired up to that button. If you add a button, you have to add code to wire up to that button. MVC is designed to sort of change that approach. The idea is you create a model, a controller, and a view. And this happens for, well, not for every web page on your site. Every view has a controller that runs it, and many controllers will use the same model. The model is what talks to your data. The controller is where the majority of your code lives, and your view only really contains your user interface. So the idea is that if you rearrange your user interface, well, it's no big deal because your code is in a completely separate layer. If you completely change your data, maybe you switch it from Oracle to SQL Server, it's no big deal. You just change your model, and the code can continue using it, and the view can continue being run by that controller. So this whole MVC, don't ask me why it's in that order, why it's not VCM or MCV, because I don't know. But this whole MVC approach is designed to separate these things out, and it's become an extremely popular development tactic. There's a lot of different languages that are sort of adopting this kind of development pattern, and some fairly significant sites are using it too. In fact, no, I just want IE, not a menu. When this site was first developed, it was actually written on the first beta of ASP.NET's MVC framework. Now, of course, the latest version of the MVC framework is ASP.NET MVC2, and that's what we're going to be talking about. Now, I should tell you that Microsoft has made kind of not novel, but they've kind of made a little tweak to the MVC approach. Not only does a controller talk to a view, but a view can talk directly to the model. And the reason you might do that is data binding. If you've got a view that you want to display some data from a database, there's no reason the view has to go through a controller to get that. The view can be bound directly to the model delivers up the data, and the view displays it. So the idea is to do that sort of data binding with as little code as possible, and so you can actually sort of shortcut the controller layer for those purposes. So both the controller and the view can derive their data from the model, and the controller tells the view how to behave. Now, just because MVC exists does not mean you should stop using web forms development, which is what we've been talking about for the previous 17 nuggets. There are pros and cons to both MVC and web forms, so let's talk about some of the upsides of MVC. When you're in a really complex application, MVC is often a little bit easier to manage complexity with because your application gets divided into your data structure, your logic structure, and your presentation structure, the model, the controller, and the view. MVC does not rely on ASP.NET's view state or server-based forms. So if you're a developer or you're working with a team of developers who really likes to maintain full granular control over your application's behavior, ASP.NET does less for you when you're using the MVC framework. Now, it does use something called a front controller pattern, which is what we're going to talk about. And in fact, I guess we could do a little picture here. MVC under ASP.NET uses a front controller pattern. So incoming web requests are always routed to the same front controller. That allows you to implement really rich routing schemes. The front controller then decides which controller gets invoked for the next step. That controller's view comes into play, and then of course the controllers can use one or more models to retrieve their data. So one of the practical approaches, and we're going to talk more about this front controller approach, but one of the practical reasons you'll see this is for websites that use friendly URLs, search engine friendly URLs. So rather than something like, mypage.aspx, oops, that's exactly what I didn't want to type. Question mark, parameter 1 equals this and parameter 2 equals that. Rather than that, which is not necessarily very search engine friendly, you might see URLs to the effect of page user / don / value / something. And then that front controller helps take these and turn them into these key equals value pairs. So rather than having this more traditional dynamic looking URL, you have a URL that seems to really communicate information but can still be used to construct a parameter set. So there's a lot of different things that you can do with that front controller pattern, and that's one of the advantages of MVC. MVC is typically, I see it at least, for large web applications that are supported by a large team of developers and web designers, and those guys need a high degree of control over the application's behavior. There's great separation, so if your developers and your web designers don't really talk well to one another, you can send the web designers off with the views, give the developers control over the controllers and the model, and people don't need to talk to one another all that often. So given those facts, you can probably guess some of the advantages of a web forms application. The web forms is an event-driven model. It automatically preserves state for you over HTTP, which means you don't have to worry about that. So line of business web applications can be developed a lot more quickly. There's a ton of built-in components and functionalities that can help you really rapidly develop applications. Generally speaking, web forms is much less complex. You're not building separate pieces to support the data, the logic, and the view. It's more or less all built as one piece, although using code behind, you still get that nice separation between the presentation, the HTML, and your actual code. So there are pros and cons to both of these. I typically see web forms used on smaller, rapid development projects, and MVC works well for complex projects that have a lot of developers working on various components of the application. When you're in Visual Studio and you want to start an MVC project, you'll see that there are specific bits here for it. In fact, let's just filter that down to MVC. We've got MVC web application in Visual C# and in Visual Basic, so you can choose whichever you want. When you start one of these by default, let's just get a C one going here. We have the choice to create a unit test project or not. I'm going to say no. That's something that we can kind of come back to very slightly, but it's not a huge deal on the exam. And boom. So we can see here we're getting a home controller by default. So this is kind of built in. Let's take a look at Solution Explorer and see what it built for us. It's putting our controllers under a separate directory, so it's giving us two by default, the home controller and the account controller. It's giving us an account model. So this is user accounts that it's setting up by default. We've got some views under here. And you'll notice that we've got a subdirectory for each of our controllers. So one controller can potentially have multiple views associated with it. Our account controller has a change password success, log on, and register view. So those are the different, you can kind of think of these in a Windows application as the dialog boxes. These are the different presentations that the account controller may need for a user. The home page has an about and index page. And then there are some shared views. So we've got a logon user control, custom control here. We've also got an error page and the site's master, sort of the template for the site. So those are all shared views that can be used across these different controllers. Content in here, CSS, just, you might stick images in there. Just standard HTML stuff is going to live in there. So that's what's in that folder. So let's take a look at how this kind of works. When I run this application, it comes up, looks like this, my MVC application, a couple of tabs, and a logon link. Notice the URL here. I'm not getting anything after the actual server and port. So it goes to whatever the default controller is, and within that controller, it goes to its default view, which would be index, and that's this home page. When I click on About, notice the URL now. It's giving me the name of the controller I'm in, home, and giving me the name of a particular thing within that controller, about. So if we go back into Visual Studio, you'll see this. Here's my home controller. So if a controller isn't specified, this is the one that gets called. If the home controller is specified in the URL, this is the one that gets called. Within here, I've got an index and an about action. So if either index or no action is specified, then this is the action that will get used. If the about action is specified, then this is the action that will execute. And this is where you specify the action. So the pattern for the URLs is controller and then the action, and then you would line up parameters and things after that. So when I'm calling the about action, I'm simply returning a view, and that's telling it return a view of this same name. Getting into Solution Explorer, I can get under the views, under the home controller, and grab the about view. And this is a little bit more of a traditional ASP.NET page. I'm going to get rid of the toolbox because while the app's running, we're not going to be able to use it anyway. And this is the view that's returned from the about action within the home controller. Index comes from the index view of the home controller, and you can see that right here where it returns view. Notice that it is setting up some view data. So this is how information is passed from the controller into the view. You can kind of think of the view as a template, and in fact, let's dive into the source code and look at this here. Here, this H2 has actually got an ASP server tag, so this is being processed at the server, and it's accessing the message element of the view data variable. That's not declared anywhere in here. It's automatically populated by the framework based on what the home controller puts into it. So the home controller sets view data message equal to this, and then that's what gets pulled out and displayed here, and that's why we see welcome to ASP.NET MVC there. So that's how data gets passed into a view from the controller, and the idea is your controller does 100% of your processing. You don't have any server-side code in here. You don't really have any significant server-side controls except for this one for the main content. And any changeable data or strings or anything else that need to get produced are put into this view data collection by your controller, and they're passed into the view, and the view simply acts as kind of a template, and you stick this little tag in here as a placeholder, and then MVC populates that for you. So let's go back to our code or our running here and click log on. When I ran that, I'm now activating the account controller and its log on action. Let's go back into Visual Studio and open the account controller. And this is popping up all sorts of stuff. The form service, membership service, it has an initialize, and these are things that happen whenever this controller is executed before a particular action is engaged. So this is getting some stuff up and running that all of these different actions might use. I've got a log on action, I've got a log off action, a register action, and you'll notice there's kind of a different version of that for the post back. So when someone posts back from the register page, we'll execute this version of the action instead. I have a change password action and its post back, and I have a change password success, and it's pretty simple, so we can probably assume that this is just saying your password was successfully changed page. Each of these actions has an associated view. There's my change password success, change password, log on, and register. Let's take a look at the log off action, because I don't see a page for that. And you'll notice that it is not, in fact, returning a view. So if I were to visit the URL account/logoff, specifying the account controller and the logoff action, it is going to use the form service to sign me out, and then it is going to redirect me to the home controller's index action. So rather than this displaying its own view, it's redirecting me to another controller and action, and then I'll get whatever that thing does. So this is kind of a little internal redirect. It is not necessarily going to result in a browser-side redirect. It's going to redirect while it's still at the server and start executing this code. So within this logon controller, or action right here, the first thing it does when we haven't posted back is just return a view. And so it's going to return a view of the same name. And that's something that I should point out about MVC. It's very sensitive about the structure of these folders and the names of these files. Your views have to be under a folder called views. Within that, you have to have a folder for each of your controllers. Within that, the view names should be the same as the action that will display them. So this is the page that defines my logon view, and we can see in the controller here that it's not making any changes to it, and so I'm just getting this default layout here, account information and so forth. So let's take a look at the source for this page. This is a little bit more complicated than the last one we looked at. Let's get rid of that to make some room. It's using some HTML action links if you want to register. It's beginning a form here, so it's got some validation information. It's sticking in some form entries, labels, validation message, labels, and so forth. So a lot of this is being generated by that back-end forms and membership services. So this is kind of the structure that these things adopt. You'll notice that I do have one model. I think we looked at that. I've got the account model, and so let's see where that comes into play. And the first place we actually see it is when the logon page posts back. So when someone submits that, it gets submitted to this same controller in action, and it differentiates because I'll display this one when someone's not posting, and when they have posted a form back, then I'll use this version of the action result. And this is telling me what model to use, and so it's going to go get the logon model, and that actually becomes a real thing. So we're then that's going in the variable model, and so we're asking it to validate membership services to validate a user from the username and password. If that comes back true, then the user was validated, and we will sign in the username and password, and we're getting all that information out of the model. So you've kind of got some, neat little capabilities here to separate all that different bits of logic. Let's take a look at what the model actually looks like. We've got several things going on here. Here's our change password model. There's our logon model. That's what we were using there. So it's just some properties here. We're checking to make sure in the register model that properties or that passwords are matching. Within the services section, we've got our membership service and the various things that it provides to us. And then at the bottom, we've also got data validation. So we've got account validation, and this is where it's checking to see, for example, if a username already exists. So all of our data logic, everything that's making sure our data is consistent and correct, and everything related to the data lives in this model. Now I want to kind of stop right here and give you just a little bit of a heads up. MVC, as already said, is complex. It's a big system, and you can see all the different layers that come in and all the different code that had to be executed just to display a simple about page. And that means there's no way in the course of the next 3 nuggets that I'm going to be able to show you everything there is to know about MVC. This is something that you should read up on. It's definitely, again, like everything else in this series, something you should play with and try and get used to. My job is to try and show you the terms, the concepts, the specific components and techniques that are most likely to come up in relation to the certification exam, and to help you really get started learning these technologies. But this is a big set of stuff to really have to tackle, and the best way to tackle it is to dive in there and start using it. So just kind of keep that in mind. I'm going to try and get every single one of the major concepts out for you so that you know where you're coming from and you kind of know when to use what and how it all fits together. But there's no replacement for that real-world experience. So one thing I want to cover right away is this idea of shared views, which is something we looked at. Here's how this works. When someone tries to access a particular page, let's say, now I can manually put the URL in for this, home/index. Get the same page. I'm just explicitly sort of specifying that. When this home controller says return a view, ASP.NET MVC needs to figure out where that view comes from. So we're in the home controller in the index action. So by default, it will go to the views folder, to the home folder because that's the controller we're in, and then look for an index view because that's the action we executed. If it doesn't find one, it will go down to the shared folder and look for that action there. It would look for an index.aspx in the shared folder. So if you have controllers or indexes that need to display the same basic thing, such as an error message, then you don't need to define that as a separate view for every single one of them. If it's going to be the same for all of them, you can drop it in the shared folder. When you omit it from the controllers folder, ASP.NET will look here next to see if it exists. So any kind of shared paging that you've got, that shared folders is a really great place to put those things. Makes it a little bit easier to have consistency across the site. Now, if you look at this model and you start thinking about a really complex application that might have 100 or hundreds of controllers, and each of those controllers having dozens or more views, this architecture, this layout can get really kind of unwieldy. And so what ASP.NET MVC allows you to do is to divide these into logical areas, and you decide what those areas are. And it really should kind of reflect the structure of your site as a user might navigate it. You might have a main area, you might have a blog area, you might have a dashboard area, you might have a forums area. So it's kind of chunk together those major areas of functionality. Now, the way you do that in the Visual Studio here is to add an area. So we'll just call this forums. Let's say we're building a website that's going to have some discussion forums. So I've created a forums area. It has its own controllers, its own models, and its own views. So it kind of segments this out into its own little private section of the website. Now, I might then add a controller. Let's add a home controller to the forums area. And when we get into that, I can then, you see, all of these things automatically get an index action, by the way. So if somebody just goes to nothing, then they'll get this default. So your URL pattern changes slightly. This now becomes forums, meaning the area, and then home, and then the action, which might be index, to run this action. When someone uses this URL, it'll automatically work. Now the trick is, you can't have a root level controller named forums because that would conflict with this area name. So the area names need to be unique between themselves, and the names of the areas cannot overlap with the names of the controllers at the root of the website. So from there I could build as many controllers as I want to. There's a separate set of shared views for this area of the site. I'm now going to have to add a folder in here for my home So I can do that through the add menu, stop right-clicking. I can do that through the home, and then any of the views, such as this index view for the actions, would go under that. So you kind of separate this out. It does make it easier if you're working with separate teams that are working on each area of your website to give them each their own area, because they can kind of be a little bit autonomous within that little area. So that's a really neat approach to it. Now there is one more thing that you kind of have to do. When you add an area like I just did, a route for that area is defined in an area registration file, and you can see it right here. So this is defining a route so that the system knows how to get to this portion, and this is where it's doing it. You can see it's adding. It's saying that forums is the area name, and then the controller, and then the action, and then some more information. And so when the action equals index, then the ID is optional. So we're adding all this routing information to it. We still have to go in and make sure that our main application knows how to get to that. So in the global.asax file, we need to make sure that we are registering all of those areas. And where we do that is down in the application start, and it's this. So that is going to go through and find all of the areas that have been defined, register them so that the front controller, the controller that automatically launches to handle getting us to the right page within the site, knows about the existence of that area. Now, what I've kind of created here is a single project area, meaning all of my areas are in one giant Visual Studio project. It's also a completely valid development approach to create a project that just represents an individual area. And really, if you're going to be assigning responsibility for each area to different developers, that's an excellent approach, because it really does make them completely self-contained. So you can kind of take whatever approach you want to. You can have each area represent a single project for the developers working on it, or you can have everything combined into one single project area. The only thing you have to be a little bit cautious about, and let me get into my index page. Here we are. It's a little bit, I don't want to say trickier. There's just an extra step involved if you want to link between areas. Normally, let's say I'm server-side and I want to build a link. So I'm going to write out an html.action link. And I've got a few different things. You can see there's 10 overloads for this thing. So let's say I want to put go to forums as the text for my link. And I want to execute the index action. I'm going to need to do that for the forums area. So it's just another parameter that you have to stick in here so that you can get from one area of the site to another area of the site. Normally you would just include the first two pieces of information, a link and then a controller action. But in order to get to a different area, you just have that one extra parameter. So let's clean up a little bit here, because we've got one more thing we need to talk about, which is routing and building custom routes. So the idea of a route is to take some sort of web browser submitted URL, some URL that the user has typed, and map that into an area, to a project, or to a controller, to an action with parameters and so forth. So you've already kind of seen the default, which is this is the controller and this is the action, or we can add one step. And this is the area, and this is the controller, and this is the action. So you can build custom routes that pick up specific patterns or types of URLs and direct them into not only a specific area, controller, and action, but also separate out any additional components as keys and values and parameters that the action can act upon to customize what it does, such as retrieving a particular post. So we might say something like we want to show, so we're going to go to the forums, we're going to go to the view controller, we're going to go to the show action, and what are we going to show? We're going to show post ID 12, or maybe we're going to say we want post title I enjoyed the movie, and the ID of that is 12. So we start to give the ability to create these very friendly URLs that, move V, I enjoyed the move. We start to create these URLs that actually have content in them, which search engines love, and we still have the data that we need in order to process this thing, and the routes allow you to take each of these different bits and use them in whatever way you need to. So that's the next bit we're going to talk about. Let me get us out of runtime mode here, and we can take a look at some custom routing. Global.asax is where a lot of this happens, and here's the default routing. So here's a name for a default route, and here's its information. The default route will assume the first URL component is the controller, the next is an action, and the third is an ID. So the default route is going to use the controller home and the action index, and the ID is optional. It doesn't have to be there in order for this thing to get activated. So this is why when we run this application, we go to the home controller and the index. Let's say we change that to about, and I'll save that and run the application. Now this is just going to the server's main URL. There's no extra parameters. Now it's found multiple types that match the controller home. You know what, that's my fault because I stuck that into the extra over here. So I'm just going to delete this controller, and that will make everyone happy. I shouldn't have called it home. Okay, and now when I run it and I don't specify any URLs, it comes up to the About page because I've now specified that that is the default route. So you can put as much stuff as you want into here. So let's create a new route. Routes.maproute. And we need to give it a name, and let's say this is going to be for our forums. And we want to take the pattern of archive/entry date. And when we get something that goes to our forums/archive/entry date, here's how we want to map that. We want that to go to a controller called archive, and we want it to go to an action called entry. And then we need to close this little construct that we've started and end it with a semicolon. Oops, and I did not want new object, I just wanted new. Boom. So now we've created a new pattern, and it maps into a separate area of our website. Now another thing you can do, I'm going to delete, well, let's just leave this one here. You can create constraints that restrict the browser requests that map to a particular route. So let's assume now that we're building a catalog. So we're going to create a route called product, and it is going to accept product/product ID, and it is going to redirect it to our product controller into the details action. And now let's say that what we've created is an action result that accepts product ID right here as an integer. So the full URL that someone might type, let me just put this in the comment, might be product/15. That is going to redirect to the product controller, to the details action, and they didn't need to specify product/details, right? So we're creating this custom route to give them that shortcut. But when they run product15, we're going to go to the product controller, to the details action, and send 15 in as the product ID as an input parameter of the details action. Now let's say we've set that up to accept an integer, and that's the way we've defined that parameter. So that will work, 15, 7 would work. That, unfortunately, will also work. That will cause a problem for us because the details action is expecting an integer. So what we might want to do is ensure that this does not match into this particular route. And the way to do that is to add a constraint. So we're going to add a new product ID, because that's what we said in our parameter here. And we want that to be, and we're just going to match a regular expression here. And I'm going to do a regular expression for 1 or more digits. and not new object. Man, sometimes IntelliSense, not so Intella. So now we've said the only way a URL will match this route is if it takes the form product/product ID and the product ID portion matches this regular expression, which will only accept digits. That means this will no longer match into this route, and so it will no longer trigger this route, and it will no longer get redirected to the product controller and the details action. You can also create custom constraints that execute your own code. Those are simply a class that inherits from the iRouteConstraint class. And once you've done that, let's say you've built one called, I don't know, match. The way you would put that in there, just shows a little bit of room here. Let's say we've done one called is local host constraint. So we only want things coming from local. So, and we've created this class called local host constraint, and that's what it looks like. And so and it's giving me this because I haven't actually created it, but this is how you would do a custom constraint for a route, a custom route constraint. That's a little, actually doing one of those is beyond the scope of what you're going to need to know, but know that it is a capability. If you exceed the capabilities of the built-in constraint system, which is largely based on regular expressions, and you want to put your own sort of ability to detect constraints, then this is the way to do it. And what you're going to want to look up is the iRouteConstraint class, because that's what you're going to inherit from in order to create one of these things. So we've covered quite a bit of ground in this nugget. We looked at an overview of what MVC is and how it works. We talked about organizing your project into areas, showed you what shared views are and how those work, and showed you what routes are, how they work, how to create your own custom routes, and how to pair those with route constraints. I hope this has been informative for you, and I'd like to thank you